Measuring sweetness. Introducing the Brix scale. Imagine biting into a perfectly ripe strawberry. The sweetness explodes on your tongue, a symphony of flavor. But how do we measure that sweetness? Enter the Brix scale, a simple yet powerful tool in the world of food and beverage. Developed by the 19th century scientist Adolf Brix, the Brix scale quantifies the sugar content in a liquid solution. 1 degree Brix is equivalent to 1 gram of sucrose dissolved in 100 grams of solution. Essentially, it tells us how much sugar is present. This seemingly simple measurement has profound implications for various industries. From ensuring the ripeness of fruits to controlling the fermentation process in beer, Brix plays a crucial role in maintaining quality and consistency. Whether you're a farmer, a brewer, or a food scientist, understanding Brix is essential for achieving the desired sweetness and quality in your products. Brix in action, from farm to factory. The applications of Brix are as diverse as the industries that rely on it. In agriculture, farmers use Brix meters to determine the optimal time to harvest their crops. A higher Brix reading in fruits and vegetables indicates greater sugar content, signaling peak ripeness and flavor. Winemakers rely heavily on Brix to monitor the sugar concentration in grape juice, which directly influences the final alcohol content of the wine. Similarly, brewers use Brix to assess the sugar levels in wort, the sugary liquid extracted from malted grains, to control fermentation and achieve the desired flavor profile in their beers. The food and beverage industry utilizes Brix extensively to ensure product consistency. From soft drinks to tomato paste, maintaining a specific Brix range guarantees a uniform sweetness and quality across different batches. Even industries beyond food production, such as pharmaceuticals and industrial manufacturing, employ Brix measurements for various applications, highlighting its versatility and importance across diverse fields. Inverted Brix, unveiling a sweeter secret. While regular Brix measures the concentration of sucrose, there exists another layer to sweetness: inverted Brix. This intriguing term refers to the sugar content after sucrose, the most common table sugar, undergoes a process called inversion. Sucrose, a disaccharide, is composed of 2 simpler sugar molecules, glucose and fructose. During inversion, sucrose is broken down into its constituent parts through a chemical reaction called hydrolysis. This process can be triggered by either acids or enzymes. The resulting solution, now containing a mixture of glucose, fructose, and potentially some remaining sucrose, possesses a higher sweetness intensity compared to an equivalent concentration of regular sucrose. This enhanced sweetness is why invert sugar is highly valued in various food applications. Understanding inverted Brix is crucial for industries that rely on achieving precise sweetness levels, especially when working with ingredients containing high levels of invert sugar, such as honey or corn syrup. Breaking down sugar acidic and enzymatic hydrolysis. The transformation of sucrose into invert sugar, also known as sucrose hydrolysis, can be achieved through 2 primary methods: acidic hydrolysis and enzymatic hydrolysis. Both methods break down the glycosidic bond holding the glucose and fructose molecules together in sucrose, but they differ in their mechanisms and applications. Acidic hydrolysis, as the name suggests, utilizes acids, such as citric acid or tartaric acid, to catalyze the breakdown of sucrose. This method is commonly used in home kitchens when making invert sugar syrups. Simply heating a solution of sugar and acid, often lemon juice, is enough to initiate the inversion process. Enzymatic hydrolysis, on the other hand, employs enzymes, specifically invertase, to facilitate the breakdown of sucrose. Invertase is naturally present in honey, and is also commercially produced for industrial applications. This method is favored in large-scale food production due to its specificity and controlled reaction conditions. The choice between acidic and enzymatic hydrolysis depends on factors such as the desired scale of production, cost considerations, and the specific application of the invert sugar. Both methods effectively break down sucrose, yielding the sweeter and more versatile invert sugar. Section 5. Measuring the unseen tools for inverted Brix analysis. Unlike regular Brix, which can be easily measured using a simple refractometer, determining inverted Brix requires more specialized instruments and techniques. This is because invert sugar, being a mixture of glucose, fructose, and potentially some unconverted sucrose, doesn't have a single refractive index like pure sucrose solutions. Refractometers, commonly used for Brix measurements, can still provide valuable information when dealing with invert sugar. However, the readings obtained need to be adjusted to account for the presence of different sugars. Specific conversion tables and formulas are available to convert refractometer readings to accurate inverted Brix values. Polarimeters offer another method for measuring inverted Brix. These instruments exploit the optical activity of sugars, their ability to rotate the plane of polarized light. Since glucose, fructose, and sucrose have different optical rotations, a polarimeter can differentiate between them and provide an accurate measure of each sugar present in the solution. Accurate inverted Brix measurements are crucial for industries utilizing invert sugar, ensuring product consistency and achieving the desired sweetness and functional properties in various food and beverage applications. Section 6. The sweet alchemy of invert sugar applications and benefits. Invert sugar, with its enhanced sweetness and unique properties, plays a starring role in a wide array of food and beverage products. Its ability to retain moisture, prevent crystallization, and enhance fermentation makes it an invaluable ingredient for food manufacturers. Honey, a natural source of invert sugar, owes its beloved texture and sweetness to the presence of glucose and fructose. The high fructose content in invert sugar also contributes to the characteristic sweetness and smooth texture of products like ice cream and soft drinks. In baking, invert sugar imparts a desirable browning effect to baked goods due to the Maillard reaction, a complex chemical reaction between sugars and amino acids that produces a range of flavors and aromas. Moreover, its ability to control crystallization helps create smooth candies and fondant icing. The use of invert sugar extends beyond its role as a sweetener. Its ability to enhance fermentation makes it a valuable ingredient in brewing and winemaking, contributing to a more robust and flavorful final product. Section 7. The art of measurement factors influencing inverted Brix readings. Accurately measuring inverted Brix is not as straightforward as determining regular Brix. Several factors can influence the readings obtained, and understanding these factors is crucial for ensuring precision and consistency in various applications. Temperature plays a significant role in Brix measurements, and this holds true for inverted Brix as well. As temperature affects the density and refractive index of liquids, it's essential to calibrate instruments and adjust readings based on the temperature of the solution being measured. The pH of the solution can also influence inverted Brix readings, especially when dealing with acidic hydrolysis methods. The presence of acids can interfere with the accuracy of refractometers, necessitating adjustments or alternative measurement techniques. Enzyme activity is a critical factor when using enzymatic hydrolysis to produce invert sugar. The concentration and activity of the invertase enzyme directly influence the rate and extent of sucrose hydrolysis, ultimately affecting the final inverted Brix value. Time is another crucial aspect to consider, as the inversion of sucrose is a time-dependent process. Allowing sufficient time for complete hydrolysis is essential for obtaining accurate inverted Brix measurements. Section 8. Sugar Science, Unlocking Flavor and Functionality. Delving into the world of Brix and inverted Brix reveals the fascinating complexity of sugar chemistry and its profound impact on the food we consume and the beverages we enjoy. These seemingly simple measurements hold the key to understanding sweetness, flavor, and the functional properties of various ingredients. From the farmer assessing the ripeness of his crops to the food scientist perfecting a recipe, Brix measurements guide countless decisions in the production and manufacturing of food and beverages. Understanding the nuances of inverted Brix further expands our ability to manipulate sweetness, control crystallization, and enhance fermentation in a wide range of applications. The science of sugar chemistry extends far beyond sweetness. It encompasses a deep understanding of molecular structures, chemical reactions, and the intricate interplay of factors that influence the behavior of sugars in different environments. By unraveling the mysteries of Brix and inverted Brix, we gain valuable insights into the world of food science and unlock new possibilities for creating delicious and innovative products. Section 9. Conclusion: The enduring significance of Brix and inverted Brix. In the realm of food and beverage production, precision and consistency are paramount. Brix and inverted Brix, seemingly simple measures of sugar concentration, play a pivotal role in achieving these goals. From the farm to the factory, these measurements guide crucial decisions, ensuring the quality, flavor, and functionality of countless products. Whether it's determining the optimal ripeness of fruits for harvest, controlling the fermentation process in brewing, or creating smooth and delectable candies, Brix and Inverted Brix are indispensable tools for industries reliant on sugar chemistry. As we continue to explore the intricacies of food science, understanding these fundamental measurements remains paramount. The enduring significance of Brix and Inverted Brix lies not only in their practical applications, but also in their ability to deepen our appreciation for the complexity and artistry of food production. These measures remind us that even the simplest ingredients possess hidden depths, waiting to be unlocked through scientific inquiry and a passion for culinary excellence.